AEG sent us the no, the spotlight one. This one back here.
This one? Tripod? No.
No, it's this one. The
Oh, that one
spotlight.
there.
Yeah, that one.
Is that for uni?
Yeah.
Which
And
uni you're at?
At QT.
Yeah.
So it's
you're doing engineering?
Industrial design.
Hard-headed, groundbreaking and ruthless, with a diverse, real-world skill set, a gift for problem-solving and a keen appreciation for design.
The client, AEG, is directed at the professional tradesman market and has a wide range of power tools, all mostly run on a 12 to 18 volt battery unit. We were given roughly 10 weeks to complete the task, and the different components and deliverables were allocated amongst the team.
Okay, let's begin.
So now we know who the client is, who we have to do it, and when we have to do it by. So the team came up with a plan to achieve a successful redesign. We will research the market and product, mainly by deconstructing it. Then as a team, ideate ways to improve the current product. Use a process design approach to iterate possible designs, and then use computer-aided design to end up with a product that is usable, productive, versatile, and effective.
It's very important, research. Research is a systematic inquiry into a subject, a specific subject.
In this case, the AEG 12-18 volt spotlight.
We began our research by deconstructing our product. To do so, we needed a T10 and 11 Torx screw, Phillips head screwdriver, flathead screwdriver, and some vernier calipers. Each component was analysed and documented, and a bill of materials for the product was created. We found that the main components of the product were manufactured through a process called two-shot moulding, whereby the main element is injection moulded PC plus ABS plastic for strength and durability. Then a rubber overmold is added for comfort and usability. We then looked at the assembly process. The light begins mostly assembled as it is off the shelf. However, thermal paste is applied and the heat sink and reflector is attached by 6mm screws. The top and bottom light casings are then closed on the light and the acrylic lens is slotted in. The left handle case is then aligned with the lighting case and the electrical cables are passed through the ribs down to the battery terminal. The case insert is attached to protect these cables via 4x5mm screws. The tension screw and washer is then added. 4x10mm T10 screws are then used to secure the light casings. A O-ring is attached, and with it, the right side handle case. Once it is aligned, the 2-part trigger is added over the button PCB. The tension screw is then secured using a flathead screwdriver. The 2 handle cases are then secured using 4x12mm T10 screws and 3x20mm T10 screws. A belt clip attachment is added using a 6mm screw. Finishing stickers are added which include safety warnings and part information. It took us about 7 minutes per assembly. However, in industry, most of this is machine operated. At this stage, we knew what the product does, who it's for, and why it's made the way it is. So, how can we improve on this?
Future's now, old man.
In our research into future technologies, we stumbled across the BMW's i8 laser headlights. We decided to explore deeper into this technology.
On my way to the BMW dealership in Brisbane. Fingers crossed that they let us film their new BMW i8 headlight.
They didn't have the BMW i8, but we made the most of it.
Wait, this is it. This is perfect. You just take a picture of the little headlights.
We tried Audi, whose R8 has similar technology, but this didn't work either. So we headed online to see how these seemingly brighter lights work. Light from 3 laser diodes are conducted into a strongly clustered beam of light. This is channeled through a mirror on the inside of the headlamp through a yellow phosphorus panel, where the blue laser light turns into white light. That is then reflected out, creating a brighter, more efficient light. With this technology, we were able to make parts of the light smaller, so the light was then redesigned. It was then modelled on Inventor. We were able to create a light that keeps most manufacturing processes and steps similar. However, creating a brighter light that lasts longer while slowing the total size and amount of materials needed.